Lead Toxicology by Brian Dorn for American Public University. Elemental lead is a heavy metal that's naturally occurring and highly abundant in the environment. It's been used in products like gas, cosmetics, ceramics, paint, batteries, and piping systems. Some examples of these products. In the 1920s, tetraethyl lead was added to gasoline as an anti-knock agent. By the 60s, 90% of gas sold contained lead. In the mid-1900s, no one doubted that high blood lead levels above 80 micrograms per deciliter could severely damage a child, but there was little research to show what level was actually dangerous. In 1979, pediatrician Herbert Needleman became the first major advocate for the removal of lead products. He led a team of research to study the effects of lower lead levels in 3,000 children. High levels averaged 36 micrograms per deciliter. Low levels averaged 24. The study concluded that children exposed to lower lead levels from dental work were subject to poor mental performance. In the U.S., from 1976 to 80 to 2015 to 16, the mean lead levels in people aged 1 to 74 decreased from 12.8 to 0.82 micrograms per deciliter, decline of 93.6%. The blood lead levels in average American children dropped from 15 micrograms per deciliter in the late 70s to 2.7 micrograms per deciliters in the early 90s, and it's even lower today. By 2000, 8 major studies were published, 6 concluding the harmful effects of lead below 10 micrograms per deciliter. It was conclusive the loss of 6.9 IQ points associated with increasing blood lead levels from 2.4 to 30 micrograms per deciliter. It was even conclusive that blood lead levels of 10 micrograms per deciliter or less could have adverse effect on children. CDC now associates blood lead levels of 5 micrograms per deciliter as a reference. While these regulations have decreased childhood exposures, existing materials, paint products, imports, and water quality issues remain a threat to children. Flint water crisis was made famous in 2015. The switch from the Detroit water supply to their own source was against the advice of professionals and without consideration of public health. What went wrong? In April 2014, the city switched their water source without considering the effects to the public. 10% of the water tests showed lead levels above 25 parts per billion, well over the EPA standard of 15 parts per billion. Still, the city stated that they were within standards. City officials and local health departments argued everything was fine, despite being confronted by pediatricians. Doctors eventually concluded reportable blood lead levels doubled in children aged 5 and younger. City finally announced they would return to the Detroit water source by October 2015. As a result, 12 people died, and 12,000 children were exposed to high lead levels in the water. Missouri 2017 argues that blood lead levels in these children are much lower than those of children in the 70s. While these findings could have eased the concerns of many parents in Flint, Michigan, the extent of the damage differed on a case-by-case basis. In the 1960s, CDC considered blood lead levels of 60 micrograms per deciliter or more to be high. This was lowered to 30 in the 70s, 25 in the 80s, 10 in the 90s, and resides at 5 today. History of the lead ban in the U.S. Continued problems from lead exposure. Primary routes of exposure: inhalation, ingestion, drinking water. Although banned by the U.S. and EPA in 1978, lead paint products still exist in many houses and buildings today. Many countries still use lead paint products, making it difficult to detect. There's a lack of research about environmental knowledge and resources surrounding lead poisoning that could be made available to urban youth. How lead affects the body. Lead mimics calcium and other valent functions. Lead produces cytotoxic reactive oxygen species affecting multiple organ systems. It causes developmental problems and for this reason is especially toxic to children and unborn fetuses. Effects of lead exposure to children. Most exposures are chronic as lead accumulates in the body over time. Even low lead levels can result in behavioral learning problems, lower IQ, hyperactivity, slowed growth, hearing problems, anemia. In rare cases, ingestion of lead can cause acute chronic effects such as seizures, coma, and even death. Most common routes of lead exposure is from inhalation and ingestion. Chelation therapy can be used to treat lead poisoning. EDTA is injected in the bloodstream to bind with lead and discard it through the kidneys. The treatment itself is controversial, except for cases of lead poisoning. In some cases, heart failure and kidney problems and resulting death can occur from the treatment. As a result, it's not recommended for use in children. The best defense for lead poisoning is to avoid exposure. The end.